What's crackin' cryptocurrency class? This is Marcus from the course, and it's my pleasure today to walk you through the smart contract that I've made for the Rock Paper Scissors course project. So let's jump right in. There's the code on GitHub if you want to check it out. So I start with giving you a high-level overview of the contract. So there's basically only two functions. This is a two-stage process where players commit the hashed versions of their game moves, and then later on, if both done that, they send the original message with the nonces. They will be compared, and if they match, the commit is accepted, and then the game is played out. The game moves are compared, where I encoded like rock as 0, paper as 1, and scissors as 2. So the contract decides if there's a winner, and if there's a winner, the two bets are sent to the winner. So if both players put in 1 ETH, then the winner gets 2 ETH to their address. And if there's a draw, for example, if both players play rock, then you enter something that's called a side game, which we'll come to in a moment. But that basically locks the players in place, so no other players can interact with the contract at that point in time, and it resets the bets they made and the commits they've made. So there's some storage variables involved, and there's also a time lock set, for example 5 or 10 minutes, that you have to play your next round. Otherwise your money will be sent to me. So there's a strong incentive to keep playing. So let's say you are in a side contract, in a side game, sorry. I also made the rule that you have to up your bets, so the players must match the pots. So if in the previous round there was 2 ETH in the contract and you have a draw, then you have to both put in 2 ETH to keep playing. That should be a P2. And then again, submit your hashes and submit your messages to reveal, and then again, either there's a winner or there's another cycle of the side game. So you could keep cycling there for a while, but it's a probability of 1/3, so it will, like with probability approaching 1, end after a while. And then again, I implemented a certain probability for the payout, which is the idea that the pot is not just played out to the players, but there's a lottery, so to disincentivize forerunning. So what I did was just hash the two nonces together and cast it as an integer. And then because hashes are or hash outcomes, hash images are equal in probability across the image space. There's something like a uniform variable, and this cutoff it looks super arbitrary, but that's the maximum value for a UN256 divided by 10, or I just left out the first digit, which is 1. So should be about a 10% probability of this condition being true, which means then all the money in the contract is played out. But of course you could do this some more elegant way, or have another probability. But the idea is that to make it uneconomical for bots to front run this, or for miners. So if there's money in the contract, but you have to play the game like 20 or 100 times to win the pot, then the idea is that you would use so much gas that you actually lose by spending all the gas and getting the pot. You end up with less money than you had before. So this is to make the game fun for future honest players. Well, there's something to do. I didn't implement the refund probability yet, but of course I think it's fair that a player gets their money back if the other player doesn't commit in time. And also the probabilistic payout should only be kick in after the side game. So the original players, if they keep playing, then the winner takes the whole pot and not spend some money or forfeit their money to the contract. This would be nice if that only happens if both players fail to reveal or there's an incorrect transaction or something else. Well, is it secure? I hope so. On the other hand, I'm a total noob, but there's this commitment scheme in place, and also kept to the checks, effects, interacts framework. So if you want to check out the code and give me some feedback, I really appreciate it. And Thanks for watching.